In this video, we're looking at arcs and sectors. If you go to your formula booklet under section 3.4, you're given the formula for the length of an arc, which is L is equal to r theta, where r is the radius and theta is the angle measured in radians. You're also given the formula for the area of a sector. So A equals a half r squared theta, where r is the radius, theta is the angle measured in radians. It is very important that you remember that the angle is measured in radians. These formulas do not work if the angle measure is in degrees. Before we go any further, let's have a quick refresher on all the parts of a circle. Let's start at the center. Then there's the diameter, a line going from one side of the circle to the other, passing through the center. The radius goes from the center to the circumference of a circle. We have a chord, which goes from one side of a circle to the other, but does not pass through the center. We have the tangent line, which touches any part of the circle only once. A part of the circumference is called the arc. The circumference is the fancy name for the perimeter of a circle. And we have a sector, which is a part of a circle bounded by two radiuses and an arc. The final part of the circle is the segment, which is the area of a circle bounded by a chord and an arc. I ought to remember a segment as part of an orange. Let's go through some examples. So example 1. A. Find the arc length AB. So we've got a circle. Its radius is 10 centimeters. There are two radiuses, OA and OB, and the angle at the center is 1.6 radians. So part A, find the arc length AB. So we have a formula. The length is r theta. Therefore, L is equal to 10 times 1.6. So L is equal to 16 centimeters. Part B. Find the area of the minor sector AOB. So what we want is this sector here. So we have a formula for the area of a sector. The area of a sector is area equals a half r squared theta. Therefore, A is equal to a half times 10 squared times 1.6. So A is equal to 80 centimeters squared. Part C. Calculate the area of the shaded segment. So the shaded segment is the shaded hatched region, and how we find that, we've got the area of the minor sector AOB, take away the area of the triangle. So we need to find the area of the triangle. So area of triangle AOB is a half AB sine C, which is a half times 10 times 10 times sine 1.6 radians, which equals 49.9786 centimeters squared. So the shaded segment area is equal to 80 minus 49.976, which equals 30.02 centimeters squared. Question 2. The following diagram shows a circle with center 0 and radius r centimeters. The circle is divided into 3 equal sectors. Points A and B lie on the circle, and AOB is equal to theta radians. A. Find the exact value of theta, giving your answer in terms of pi. Well, we are told that the circle is divided into 3 equal sectors. So that's one sector, one sector, one sector. So the angle at the middle, theta, is 1/3 of the total angle at the center. Well, we know that the angle at the center is 360 degrees, which is equal to 2 pi radians. So therefore, A, theta is equal to 1/3 2 pi. So theta is equal to 2 pi over 3 radians. Part B. The area of the shaded sector AOB is 3 pi centimeters squared. Find the radius of the circle R. Well, we know that the area is equal to 1/2 r squared theta. So therefore, 3 pi is equal to 1/2 r squared times 2 pi over 3. When you rearrange that, you get r squared is equal to 9, so therefore r is equal to 3. Part C. Find the length of the chord AB. Well, we have the triangle OBA, which we know that the radius is 3, so OB is 3, OA is 3, and we want to find AB. We know that theta is 2 pi over 3, so we've got two sides and the angle in between, so we can use the cosine rule. So therefore, AB is equal to the square root of 3 squared plus 3 squared minus 2 times 3 times 3 times cos 2 pi over 3, which is equal to 5.20 centimeters to 3 significant figures.